Hey kids, welcome back to Guitar Quackery Live. We have something to talk about, and that's all we're going to do today. Today, no, I've been working and talking, but that's all we're going to do during this live stream is just talk, which isn't uncommon for live streams. It's only uncommon here, because here at Guitar Quackery, when we do a live stream on the channel that's called Guitar Quackery Live, or at least I work. And today, well, I am working, see? But I am, working the way Michelangelo was working, when he was caught, chilling once. There's an anecdote. So he was just, I guess sipping on a glass of wine or something and just chilling. And someone says, hey, what are you doing? And he said, well, can't you see that I'm working on my next statue? Because that's also work. So I am working. I'm just not going to be working with my hands. I'm going to be working with my mouth and with my brain. We have this treasure here. Vintage Gibson mandolin. How do you know it's a Gibson? Well, there's ways of knowing that it's a Gibson. It's a Gibson. It says right here. It says the Gibson. If this camera wants to focus right there, you see, the Gibson. All right. Yeah, no big deal. It's just a headstock repair. Yeah, not really. So that's a really challenging headstock repair. And right now I'm live streaming, so I titled this live stream Reassessment. Okay, because I had time to think. So some projects are just like that. You take the guitar, or in this case the mandolin, and I just need to put it away for a few weeks and think. And during those few weeks, I was working on it. I was cleaning up the end grain so that I can put the headstock back together on the barrel, and I made some progress. So this now fits perfectly. Okay, so I can put it together without crushing any of the end grain. So this is a perfect match. So what's the problem? Well, this type of instrument has 8 strings at really, really high tension. And the tension that pulls the headstock across the barrel is really high. I don't know how to express it in pounds or newtons or kilograms, but it's high tension. And I can reglue it, and I can almost guarantee that it's not going to hold up. Okay. So what's the problem? The problem is there are multiple problems with this. Surface area is very small. Then the wood is like that. So yesterday I spoke with Ian Devlin. So he is a really experienced luthier, and he runs this thing on Patreon called the Loot group, and I'm a member of that. It's like a membership thing. So if you are a guitar technician or a luthier or a repair technician or a builder, whatever, you can join, and then you can talk to other people from anywhere in the world. You can log on to the Loot Along, which is a 24/7 Zoom thing, and people can meet each other virtually. And yeah, talk, exchange ideas, ask questions. So I asked Ian about this, and the first thing he said when he saw this was, "I don't like your odds." So let's talk about this. What are the challenges with this? First of all, the glue joint area is very small. It's just this mahogany here. Forget about this. This is the headstock veneer. It's not structural. So this part of mahogany here. Here we have some end grain. It's not going to hold much. And here we have this little surface there. That's it. So this matches this, and this matches this, right? Because it goes like this. Okay, then we have this maple part. And as you can see, it fractured at an angle. So this is how this was made incorrectly. So these wood fibers, so this whole maple block was inserted, when they built it, to reinforce the whole neck, because the mahogany isn't that strong. But you can see that they cut it incorrectly. So it splits in this direction. So yeah, I can reglue it, but the wood fibers are going in the wrong direction. They should be going like this, not like this, not crossing like this. Then we have this part here. So you can see how this is yellow, and that matches this part here, mahogany. This was never glued onto the mahogany. There was an air pocket. And I can show you this through the microscope. So now we are going to look at first the maple part, okay, and then the mahogany part. So here we're looking at the maple, and you can see this yellow is glue. And you can even see little particles of glue. And that's because this surface was actually never really glued to this surface here. There was just an air pocket. And we can also zoom in on this one. And you can see the old glue, dried up, little crystals. So I can remove them, I can scrape this, but I am just going to end up with a fresh air pocket. So let's go back to this. So we have a little surface, glowing surface here. And here, mahogany, very weak. This is weak because the wood fibers are going in this direction. This is weak. This is non-existent because there's an air gap between this mahogany. There's an internal air gap between this and this. As you can see, the glue was there, but then the glue shrinks when the moisture evaporates and you're left with an air gap. So that's nothing. So it's non-existent, okay? And now you need to put this together. So yeah, I can glue it back, but as soon as we put the strings on, this high string tension is going to snap it again. Now, are there any solutions? Yeah. And Ian Davlin yesterday said something very interesting. He said this wood grain is, this wood is so old and brittle. He said it's with one foot in the grave and the other foot on a banana peel. So what can we do? Well, I guess there are options. So one option would be, first, to reglue this. So that needs to be done first. But like I said, that's not enough. So then we need to reinforce it somehow. So one option would be to remove the entire fingerboard after regluing the headstock, and then remove the headstock veneer, and look at this inlay. So that's going to all get crushed and damaged. There's no way to remove this without damaging it. Then once that's removed, in theory, in theory, I could then dig out this maple part and also the maple here, which I'm sure extends all the way to the end of the neck. Just dig it out and then insert another maple block or carbon fiber, and then repair the headstock veneer. So I'm sure that's going to cost more than this $6,000 mandolin, right? That's what I was told it's valued at. Then there's another option, to reinforce it from behind. So reglue this first, and then use a router to route out this entire line. Okay, all the way and into the headstock, and all the way down to the fingerboard. Okay, and here is going to have to go up into the headstock, and then once that's routed out, then insert a carbon fiber strip into it, and then finish it on the outside and somehow hide it here, or just keep it as a decorative line. So the carbon fiber strip would be probably double this thickness, and much taller than this, and I guess that would hold up. Now the problem is, how do you jig it up? So this is not a flat surface. You can't just put it on some kind of a jig and hope that it's not going to move. So we can make a plaster mold so that it fits and doesn't move onto a plate. Same with this. So once this is all glued up, re-glued, so make a plaster mold. So now it's firmly seated on the plaster mold, and then somehow build up a jig on mounted onto the same plaster plate, so that the router can be precisely moved in this direction, up and down. And the router needs to go up like this and then like that. So it's possible, but that's more than just regluing the headstock in a conventional way. And then where do we get that carbon fiber insert? I would have to make it. So I would have to make a mold for that and manufacture that and then that would be used just for this repair. So we are talking about significant amount of work, quite a few hours spent on this. I can't even start to estimate how many hours. I don't know. And also, that's the type of repair that I don't think anyone has ever done. It was Ian Davlin's idea, and he's never done it. And I don't know, I can't think of any other possibilities. So that's that. So, like I said, this is just an assessment or reassessment of the situation. So I'm told that this is worth $6,000. I think that's what the customer told me. Let me check. I don't know, because I'm not a collector. No, $7,500, $7,800. Okay, if it is, I don't know. So it's worth repairing. But how many hours is it going to take? And is it really going to hold up? I guess it would, you know, with the carbon fiber reinforcement. But I don't know. I don't know how many hours it will take to do that. Yeah. So this is it. This is the end of this live stream. Styrene Builds says Mandos can get expensive. Yeah, they can. I'm not sure if you are referring to just the instruments, which can get expensive, or the repairs of the instruments, or both. Yeah, so that's that. So we also have to ask the question, why did this break to begin with? So the customer told me that this just, you know, broke. That's it. It wasn't an accident. It just broke. So this tells me that if we just re-glue it, it's just not going to hold up. But we do need to re-glue it as step one of the repair. Okay? And you know, it always looked like a challenging job to me, but now that I had time to think through the whole thing, only now do I realize just how challenging it is. And I'm making this video so that the customer can watch it, and then we'll discuss what he wants to do. Yeah. That's it, my friends. So I'm going to say goodbye for now. And I'm not sure if I'm going to be doing any more streaming today, or maybe I will. We'll see. Okay, bye-bye.